we have to apply the product rule. Always inspect the function. Factor if you can, if it's needed, if it makes your life easier. Simplify. Don't start doing anything before you inspect the function. Visually, of course. Well, see, it's a product, so I have to use the product rule. So first function prime, 2t e to negative t plus t squared e to negative t and times negative 1. I notice that I can factor out a t and e to negative t. T and e to negative t, so I'm left with 2. T, one of them is out, there is a negative, and e to negative t is out. So this is the same with negative t, e to negative t, t minus 2. You already know, and I'm hoping that you learn at least that from me. So always inspect the function, always factor if you can, always simplify, and always present descending order. Once you get into the habit of that, you're going to always make your life easier. So you can say, why did you do this? Because I know what's going to follow, right? I have to study the sign of this. That's why I already prepared it for that. Of course, this is not necessary for v of 1. For v of 1, this is 1. This is e to negative 1, which is 1 over e. And this is 1. So 1, 1, e to negative 1. Always write the measurement unit. Whenever you get, whatever you get, it says t is measured in seconds and s is in feet. So this is in feet per second. Yes, in this case, I would approximate it, only because what is 1 over e? I have no idea, right? So I used to have a calculator, but I do have it brought up already. I'm ready for that. So what is it? So I prefer doing this. You can do what? Oh, you can have other options. So I want to put negative 1 on it. So see, the older calculators are different. Anyway, so this is 0.3679. 0.3679 feet per second. Then I go back to when is the particle at rest. Okay, so that's another reason why I factored it. Got it ready. So particle at rest, v of t equals 0. No velocity, right? So obviously from here I don't have to do anything because I have it, either when t is 0 or when t is 2. Of course in seconds. This is never 0. E to negative t is 1 over e to t. Never, ever 0. Unless t approaches infinity, but we're not talking about that. Good, so because I already did the work, I didn't have to write anything here. I'm just looking at this. Imagine that I set it equal to 0, and I get t equals 0 and t equals 2. This can never be 0. Never 0. Okay, then I move on. And it says, when is the particle moving in the positive direction? So of course I'm going to create the table for both. I don't really be interested in. Okay, so in number 4, I get the table going where I have the velocity. I already anticipate what they are going to ask. And also I'll come back to this and draw the conclusion. Okay, so we are told that of course, the time is positive. Okay, so they're asking us to basically put in this in here, right? 0 and 0. And I study the sign. This is always positive. Don't bother with it. So when I plug in 1, this is negative, but this is also negative. So the sign here is positive. When I plug in 10, this is negative and this is positive. So I already know what's happening here. So for the positive direction between 0 and 2 seconds, for the negative direction between 2 and whatever. I don't have to write anything. This is it. That's all I need. If I see the sign here and the sign here, then you don't have to write specifically on the side anything. Then find the total distance traveled. So they're asking us everything between 0 and 6. So I already get my table ready. Of course, I'm not interested in infinity. So now they want us to find the total distance, right? So find the total distance traveled during the first 6 seconds. So now I know that this is positive. I don't really need the absolute value. F of 2 minus f of 0 doesn't need absolute value, but we're going to write it just to make sure you don't forget it. Plus, absolutely, I have to write the absolute value between f of 6 minus f of 2. So the total distance the absolute value of f of 2 minus f of 0 plus, which again does not need because it's in the positive direction, plus f of 6 minus f of 2. All I have to do is just plug in the function and get all these values. So I go back to the graphing calculator and I punch it in y equals, clear whatever you have in there. Let me make sure that I am turning this off just in case. Okay. Good. So I have t squared times e to negative t. That's the function. So with second and table, I plug in 0. Of course, I know the answer is 0. I don't need to do that. Anyway, 2 and 6. And also go back and highlight. So you can get the full and use 4 decimal digits or whatever. So f of 2 is 0.5413. Then f of 6, so that's plus f of 6, it's 0.0892 minus 0.5413. Okay, so 0.5413. And let's see what we have here, 5413.0892. I think I have here 1 and 2 and 5 and 4. Correct me if this is not correct. So 0.4521, because it's in the absolute value. So that's why I reverse them, because I have to. It would be a negative number, but I have to use the absolute value. Okay, so what do I have here? I think I have 43990 measurement unit, and it has to be feet because we are talking about total distance, so this must be feet. So let me know if I made any error anywhere. Okay, then the next question. Okay, so yes, we can do that. So it starts here at t equals 0. It goes, where's my table here? It goes to the right 2 seconds and goes 0.54, so 2 seconds. So t equals 2, and s of 2 equals, if you want, 0.5413. And then for the next 4 seconds, it goes to the left, and this is a little bit more than what, so it goes, this is 0.45, so it stops right here. So this is t equals 6, and it went this way, 0.4521. Okay, so this is not s of 6 now. So this distance is 0.4521, and this distance is 0.5413. And I'm going to wipe that out. Now, if you want to put it in terms of time, you can. Then I would say 2 seconds this way, 1 second 2, but 4 this way. So t equals 0, t equals 2, t equals 6. So this is for about the distance, and this is about time. Okay, then what we have, find the acceleration. We don't have to graph it. They have to be, it's graphing calculator. And when is the particle speeding up and slowing down? So in number 7, I have to find a of t. Where is my t? Of course, I'm going to differentiate this. So I have 2t e to negative t minus t squared e to negative t prime. I'm not going to differentiate the product. I already have 2 products to deal with here. So this first function prime is 2 e to negative t and plus 2t e to negative t and times negative 1. Now be very careful with negative. Leave it alone. Leave it outside. Open parentheses. So this one I know. We just did it a second ago. 2t e to negative t minus t squared e to negative t. Because we just differentiated that. Okay, now I will distribute a negative sign. So I have 2e to negative t minus 2t e to negative t minus 2t e to negative t and plus t squared e to negative t. Awful, but that's what it is. So I can combine these as negative 4t e to negative t and plus t squared e to negative t, and of course I will factor out e to negative t. And I have t squared minus 4t and plus 2. And they're asking us for a of 1. So 1 plus 2 is 3, minus 4 is negative 1 over e. And this is approximately a of 1. One more time, this is at 1, right? 3, yes, minus 1, that's the negative, and e. Okay, so we just calculated that. And what was it? 0.3679, but this is feet per second squared because we're talking about acceleration. And finally, I have to study the sign of the acceleration, find where it's 0, study the sign, and then draw conclusions. So I know that a of t is 0 only if this is never 0. This is never 0 and positive. When t squared minus 4t plus 2 is 0. And yes, you can do this with a graphing calculator. I'm fine. If somebody is in calculus and doesn't know the quadratic formula, there is nothing I can do at this point. I know you know the quadratic formula, so I'm not worried about it. Okay, so number 9. Okay, so the first coefficient is 1. Second coefficient is negative 4. And they have to be in this order, correct order. And 2. And I want to get the solution. So I get T1 equals 0.59 and T2 equals 3.41. Fine. I go back to the table. 0.59, 3.41. And now I study the sign here, here, and here of the second derivative. But this is positive. So this is a quadratic function opening up. In between solutions is negative. Outside is positive. I don't have to do anything. You can plug in numbers. So put this function in the graphing calculator, and when you plug in 0, you'll see you get positive. When you plug in 2, you'll see you will get negative. When you plug in 6, you will see you'll get positive. So now I have my conclusion. Speeding up because they're both positive. Slowing down, one is against each other. One forces the other one to slow down the particle. Same direction, both working to speed up. Opposite, speeding is slowing down. Is this okay?
Yes, thank you very much.
Perfect. Is it better, everyone? Are you okay? Okay. What else we have here? So we want to go to related rates now. Let me put these pages in the correct order, because sometimes, very rarely, I scan them in the incorrect order and then I have to start again.